So we've got a few good sessions coming up this afternoon after Frank's session that I just wanted to highlight, later on this morning. So following Frank's session, we will have a session by Microsoft Cloud Evangelist, Sarah Lean, talking about delivering your data center migration successfully. So those organizations that are looking over to Azure, looking at migrating workloads, that's going to be a Just Watch session for you. And then next of all, we will have a VxRail session by Mike Orff. But hopefully we've sorted those gremlins out now. So back over now to Frank for his session all around vSphere.
I'm Frank Denneman. I'm a chief technologist at VMware. I work for the Cloud Platform Business Unit, where I focus on compute resource management and machine learning. And for today, I would like to talk to you about creating a developer self-service platform with vSphere 7 with Tanzu, while maintaining governance over your infrastructure that you manage. So the agenda is quite simple. We start off with, are you going to build or pull your containerized workload? How do you create a self-service consumable pool of resources? And what type of consumption strategy can you apply? So Barry mentioned it, Duncan mentioned it, we're seeing a change of types of workloads. Where it was a VM-centric type of data centers first, we are now seeing more or less a shift towards the cloud-native structure containers. IDC looked at data centers and they did a research, and over 70 million virtual machines are running in data centers today. But they are expecting to see 500 million or even more containerized based applications running in your data center over the next 5 years. Now you might say that, look, this is fine, but containers are typically a construct used by developers, and I don't have a developer team. So is this still relevant for me? And it appears that, and so 451 Research looked at over 200 software vendors, and they found out that most of them are looking or are actually using containers as a distribution method for their new software. So that brings us to an interesting scenario, because we have this containerized application, but where do you run it on? It cannot run on thin air, so you need to have this platform. And typically a container or a containerized application is of a distributed manner. And that means that there are more containers working together. So you want to orchestrate them. And one of the most popular orchestration systems nowadays is Kubernetes. And Kubernetes exists out of different components. You have two types of nodes. You have a control plane node and a worker node. And so the control plane node allows us to orchestrate and start up and power down and restart the containers. And so you need to have this highly available control plane for production environments. And typically that means you need to run 3 control plane nodes. That's due to the use of etcd, which is a quorum-based key value store. Now the other type of node that you're using is a worker node, and that worker node runs the actual application itself, the actual containerized application itself. So the size of the node, of the worker node, is dependent on the application requirements. The size of the Kubernetes control plane node is dependent on how much operations are you going to push towards your Kubernetes cluster. How many times are you going to restart? How many times are you going to do things towards your application itself? Now, the key is that if you look at a lot of the past presentations about Kubernetes, they typically talk about this is the end of the world for virtual machines. This is the way to go forward. It's a black and white world. Everything is going to be containers. Now, maybe if you are a startup, or maybe if you are working for an organization who do a lot of skunk works, projects typically spin out a particular development team, production development team, or service development team, figure some cool new service, and then bring it back. For those type of environments, yeah, maybe you can run it completely new IT environment. But for the majority of us working for organizations who've lasted many, many years, you are already running services, business services in existing, on your existing infrastructure. Typically, that means bare metal, mainframe, and virtual machines. And so what you typically see, and this is what we expect, and with customers who are already deploying containers, what we see is that the newly developed service augments the existing service already running in your data center. So take, for example, an online app, an online banking app that can be developed in a container, but it still needs to interact with the accounting services, which runs in a virtual machine, which typically hits a database, which hopefully runs in a virtual machine as well. And so now you have this combined environment, and that means we are going to see a lot of new challenges. So for the developer who wants to control and develop its containerized application, he or she is getting these questions like, how I'm going to develop this app. Not only do I need to understand Kubernetes, but also how can I interact with my existing services? How do I operate it on day two? I can do some maintenance on my stateless container or my stateful container, but I need to interact with that service that runs on VMs as well. How do I coordinate? And so which tools can I use? And so for the IT ops teams, it's like, how can I create this platform that not only runs the virtual machines very well, but now needs to run this containerized structure, this Kubernetes world, efficiently, stable, but also performant. And of course, how do you secure it all? So with these challenges in mind, we started to work on developing services for the containerized world. And in 2016, the storage and availability side of our business unit, which Duncan works for, they started to work for Project Hatchway. They started to work on Project Hatchway, which was a cloud-native storage service. Now in 2017, we started to work to integrate Kubernetes into vSphere, and that has resulted in two flavors: vSphere 7 with Tanzu, and with the acquisition of Haptio, we are able to also provide Tanzu Kubernetes Grid, or short TKG. Now vSphere 7 with Tanzu allows you to run containers as native pods inside vSphere, whereas Tanzu Kubernetes Grid is a upstream compliant Kubernetes deployment or version that runs in virtual machines and that is supported by VMware. And now these two combined, they create this self-service platform for developers, but it still allows you to maintain the governance over the infrastructure that you manage. So how do we do that? How do you create a self-service consumable pool of resources? Now, you do that by installing vSphere 7, and with update 1, you can also use vCenter Server Network. And that's a fancy name of using a distributed virtual switch and a virtual load balancing tool. We start off by using HA proxy. We're introducing more virtual load balancing. And if you want to keep up with the news, I suggest you follow Cormac Hogan on Twitter or go to his website, cormachogan.com, to get the latest news on these developments. Now you can also use NSXT, but that takes a lot of effort. So what I've done in this presentation, I've concentrated on using the vCenter Server Network. So I'm using distributed virtual switch, and I deployed a virtual load balancer, the HA proxy. And so once I ticked all the boxes for workload management and I installed it, you will see what you see on the right side of your screen. You will get treated by a namespaces resource pool, and that houses all the TKG clusters and all the vSphere pools from now on. And what you will see are 3 supervisor control plane virtual machines. Now, if you have enabled workload management, we tend to call the vSphere cluster a supervisor cluster. So if you hear me say supervisor cluster, that is a vSphere cluster with Kubernetes enabled. Now we deploy 3 supervisor clusters because we want to provide you with a control plane that is highly available. Now that control plane is particularly developed for developers themselves. Because what we do is we expose a Kubernetes API endpoint. And so the developer can communicate with the vSphere platform in Kubernetes native commands. So now you have 2 different teams consuming the vSphere platform. We have the ops team deploying virtual machines, and we have developers deploying maybe vSphere pods or TKG clusters that allows them to run containerized workloads. But now you can say that, look, now I have this group of developers who are not really interested or not really well known with the way we manage our infrastructure ourselves. So how can we guide them? You can also say control them, but I think that's a little bit too restrictive. How can we guide them in such a way that they can consume the infrastructure in a self-service manner, yet still allow enough resources left over for us to consume? And that is the role of the vSphere namespace. And so the vSphere namespace helps the ops team to allocate a particular set of resources, a particular a set of permissions and storage for the developer. So it becomes this guardrail. Now, how do you create this namespace? You go into workload management, and there's this nice blue button that says create namespace. If you click on that, you need to select your vSphere cluster with 10.2 or your supervisor cluster. You need to give it a name. And so because I want to create this namespace for this online bank app, I use that name. And then you just select the network present for your TKG clusters and for your environment. And that's basically it. You click on create, vSphere does its magic, and then what you will see is underneath the namespaces resource pool, you will see a online bank app namespace. Now you see a new icon, and when you click on that icon, you will see the namespace, and you will see the information and the services provided to that namespace. So one of the first things that you need to do is you need to create a role-based access control, RBAC. So in this scenario, I created a group within vSphere, within vCenter, and I call them online bank app developers. And they can edit the resources inside the namespace itself. The next thing, what I need to do is I need to provide a set of storage policies for the containerized workload to consume, for the persistent volumes for the containers to consume. And I can select one or I can select many. Now the next one is I want to, or I can limit the resource consumption. Here you have a set of commands that list the physical allocation of these resources. And once you set that, you will see on the summary page of the namespace the limits available. On the left side, in the capacity and usage card, you will see the actual consumption. On the right part, you will see the limitation. And now this namespace is ready to be consumed. So now the developer can instruct the supervisor cluster to actually deploy a TKG cluster. And so a TKG cluster is deployed inside that namespace, and eventually it will consume the resources of the ESXi hosts that are a part of that vSphere cluster, that supervisor cluster. And so that new TKG cluster, that exposes a new API endpoint. And so to give you an idea what you need to do in order to install or deploy a TKG cluster, you need to provide that developer the virtual IP of the supervisor cluster. And because you already provided a RBAC configuration to that namespace, once the developer logs on, he or she will see the namespaces that he or she is allowed to access. Here I logged in myself, so I saw or I see all the namespaces in my supervisor cluster. Because I'm at the root level, I need to change the context. That basically is I need to go into the namespace. So I selected and I switched to the context online bank app. I then looked at a particular YAML file, which is the infrastructure as a code file, which I'm going to talk about later. And that defines the actual sizing and the configuration of the TKG cluster. And the last step is to actually apply that YAML file, which is Kubernetes speak for deploying a machine on Kubernetes. So once that TKG cluster is up and running, so you have a control plane node and you have some worker nodes, the developer can now access the API endpoint of the TKG control plane node and deploy the actual containerized workload. And that's basically it. Now, the problem is, how can we make sure that the developer doesn't overconsume the environment? What type of rules can you deploy? What type of conversation can you have with your developers? And so you need to come up with a consumption strategy. Help them understand the way you run your infrastructure, which you've been running for many, many years. And so one thing that we already discussed was that deployment YAML file. And if we zoom into that deployment YAML file, on the left side, you will see the topology. And I've created a very short YAML file. You can specify a lot of features, but that wasn't really relevant to this story. So I just did the utmost well, necessary information, and that is the virtual machine class and the storage class. And what you see here is that I have to specify a control plane, the number of control planes, and the class itself. Same for the workers, number of workers, and the class. So now you can think about the cluster configuration of a Kubernetes cluster. And the actual virtual machine class will impact the overall resource availability of your virtual infrastructure. Because on the right side, you will see these 8 types of sizes. There are 8 types of sizes and 2 types of guarantees. There's this best effort that doesn't have a guaranteed resources, and there's the guaranteed which have a full resource. So I created this handy table in which you can see that if you select a size with a guaranteed moniker, that size will get a reservation that's equal to the CPU configuration, and that's equal to the memory reservation. So think about this. A developer can go into a namespace, and if you have not set a limit, and if the cluster has enough resources, the developer can deploy a 3 control plane node with a virtual machine class of 8 times extra large. So that means that every control plane node has 32 vCPUs with the full reservation and 128 gigs of memory with the full memory reservation. Problem is, at this point in time, we cannot control the number of virtual machine classes in a namespace. So one of the things that you want to talk about to your developer, or have this master class to your whole group of developers, is think about your control plane. Are you going to run it in production, or are you not going to, or are you going to run it in non-production, a test environment? Because if you're not going to run a production environment, maybe one will suffice, because you only need to instruct your TKG cluster to run your containerized applications. Do you need to have guaranteed resources, or will best effort make sense? The number of worker nodes, same thing. Do you need to test the way the application works, or do you need to test the orchestration, and do you need to understand how these particular containers interact with each other? Because that changes the consumption model quite differently. Now, if you're unable to have that conversation, you can also use a limit. And one of the cool things is that namespaces are backed by resource pools. And that means that we can set and alter resource allocation settings without actually interacting with the virtual machine configuration, because TKG virtual machines are actually virtual machines. And by setting limits on a resource pool, we actually allow vSphere to distribute the limits across the different nodes, the different ESXi hosts, where the cluster, TKG cluster nodes actually run. So it's a more dynamic way. And so you can say that, look, I want to have a 50 gig limit. And that means that we are going to restrict the number of guaranteed resources that a developer can allocate to its TKG cluster. You can still run 6 best effort clusters, but now that means that those virtual machines need to allocate those resources on their share basis. Now, what we introduced in vSphere 7 is a scalable shares resource pool functionality. Funny or interesting thing is that both Duncan and I are the inventors of this scalable shares, and I wrote a lengthy deep dive on my site. Now, mind you, this is a 20-minute read according to the statistics, so please take some time or reserve some time in order to understand this functionality. But overall, I created this list of questions, and I will share my presentation so you can download it and you can look at these questions a little bit longer than a few minutes. Is that these are the questions that you want to bring back to your organization to think about a consumption strategy. Because what type of Kubernetes landscape do you expect? Are you going to deploy a highly dynamic set of Kubernetes deployments which are primarily used as tests? So think about the churn. Think about how many developers will actually interact with vCenter, because there's still a maximum concurrent number of vCenter provisioning operations. I believe it's still at 20. So if you have like thousands of developers all hitting that vCenter, they are going to see some lag and see some impact on responsiveness. Think about the expected lifetime of a Kubernetes cluster. Are they going to spin up a Kubernetes cluster, do some things, and just break it down again? That will impact the overall performance of your environment. So think about whether you want to run VMs next to your TKG clusters. Maybe you want to separate a vSphere for your environment that runs these TKG clusters on your supervisor clusters. Now, if you're going to create an environment for your production Kubernetes cluster, think about your control plane sizing and your worker node sizing. And maybe you want to isolate production from your developers. We have introduced HA many years ago, and we've refined vSphere HA up to a point that it can actually outperform some of the Kubernetes availability functionalities. So educate your developers on the power of vSphere HA, and instead of them going to a 3 control plane node, let them test it out with a single control plane node for your test environment. And with that, I would like to thank you for your attention, especially your patience with my fumbling in the beginning. And the last thing I want to say is, I believe that you're going to either build or pull containerized workloads on your vSphere 7 platform. And I believe, and I think the company VMware believes as well, that vSphere is the foundational building block for the infrastructure that is a home for new workloads. And with that, I would like to thank you.
Thank you ever so much, Frank and Duncan, for those sessions this morning. It's been really interesting to see the evolution of vSphere over time, and for it now to be the platform to lead you not only with your virtual workloads, but your developer-led workloads. There was a lot of conversation a number of years ago, was, are containers going to replace VMs? Is this the biggest challenge that VMware have ahead? But much like Microsoft loves Linux, VMware loves Kubernetes. And I think that has really come to the forefront. No matter what type of workload it is that you are looking to run, you can do that onside vSphere. Now we're handing the focus over to you guys to pick what is important to you, what sessions you want to focus on next. The next two sessions that we've got is Sarah Lean with Deliver Your Data Center Migration Successfully, focusing on migrating to Azure. And with Mike Orr from Dell EMC, what's next with VxRail. We then have later on this morning a session with Runecast, Kev Johnson, a great community advocate as well, looking at their product and an introduction to Runecast. And Computer World's very own vExpert, Ben Evans, looking at vSphere Lifecycle Management with Dell Open Manage. So if you're using Dell servers inside your data center, I highly recommend you look at that session. And then throughout the afternoon, we've got a wide range of sessions. I recommend you check out the virtualization panel, which will really sum up a lot of the things that we've spoken about today. Thank you ever so much for tuning in to this first part of Define Tomorrow. I will be back tomorrow morning where we're looking at workspace. I'm really, really excited to look at the workspace technology. Anyone that knows me knows this is an area that I'm very passionate about and spent a lot of time. So thank you for joining this part. Enjoy the rest of the sessions for today, Infrastructure Day at Define Tomorrow.